The breakthrough of Atlas it's an economic breakthrough rather than a technology breakthrough.
Where do you draw the line between what the hardware needs to get right and then what the AI brain needs to get right?
Whoever controls the future of physical AI is whoever controls the brain. I don't know if that capability is something that anyone's going to get for free just because we have AI now. Can this thing run and run and run in challenging environments? The economic breakthrough comes when you have a single hardware investment that can be retasked solely through software. I also don't want to have to build a million software interfaces. I bought a robot. How do I interact with it and tell it to do something brand new?
Brian, what fuels your mornings? Coffee, tea, chaos, or something else?
Definitely coffee. I use specifically a toddy cold brew system, which is like a highly concentrated but low acid way to do cold brew, and it has to be atomic beans from Salem, Massachusetts. So I'm not particular at all about
No,
my coffee.
not at all. Yeah. So wait, it's a home system for cold brew
Yeah,
specifically?
it's just basically like a plastic bucket, and you just do a coarse grind of whatever bean you like, and you let it soak for like 24 hours. You're actually supposed to water it down because it is a concentrate when you drink it, but
Yeah.
I take
Go
it I
straight.
take it straight. Yeah.
I love that. That's why I like cold brew because it's so much stronger. What's the first technology you remember being obsessed with?
um I think aviation technology. I actually was born on a B-52 Air Force base. So
Very cool.
we had the Thunderbird shows every summer, and there were just always planes over our head, and that's where my dad went to work every morning. So that was definitely my like intro to tech and
Yeah.
machines.
That must have been so cool being a kid and growing up around that.
It was really cool, but it's the same thing when you're a child and that's your first environment. You don't know that that's
Right.
just not what
That's all
every
you know.
kid is doing, right? There's just airplanes everywhere.
Yeah, how sad when you like move away from there and you're like, oh, the rest of the world isn't
Yeah.
like this.
Yeah, I missed that. Yeah.
Yeah. What's one thing people misunderstand about building in robotics, AI, or hard tech?
Oh my gosh. I mean, it's how could you not misunderstand it? I think with the way that so many different things are happening and the way it's kind of simplified and glossed over in the media. I think that everyone suffers from kind of the same problem that they have with really any of these technologies, which is that you underestimate it in the long term and overestimate it in the short term.
Yeah.
I'm constantly telling people like you have no idea how hard it is to like the idea that where we're at with language models and like chatbots is like their product manifestation, getting there with being able to just talk to a robot naturally and have it generally capable and kind of doing whatever you need it to do is such a wide gulf, and there's so much work to be done, while at the same time being like totally possible, right? That's totally a possible future that we're building. And I actually feel very optimistic we'll get there, but it'll be hard work.
Yeah, that's really true. Yeah. Okay, last one. 10 years from now, what would make you proud to say we helped make that happen?
I mean, this isn't specific enough, but I just love the idea of kind of having any part in bringing, some kind of new knowledge into the world, right? And it is a very small part, right? I work with a lot of brilliant people on everything I do, and I'm fortunate to get to participate in these things. Um, but kind of being able to look back and say that, hey, these robotics that are all around us and that are a natural and beneficial part of our daily life. I was there in the early days, and I remember my hiring manager taking me aside on my first day in the office at Boston Dynamics back in like 2019, and being like, don't you feel that energy? Doesn't it feel like the beginning of like personal computing or something? Like, isn't that so
Yeah.
exciting? And I also like that it's a really hard problem. I sometimes somewhat tongue in cheek will be like, hey, I'll probably, die before like all of my objectives are met. But like I like contributing to a really big problem on kind of a time scale that's maybe broader than just what I get to experience.
Yeah, it's a really good point. And I think it's also like a very realistic mindset of timelines in what we're working with and
Yeah,
enjoying
we're in
that
the culture. We're
journey. And
such
yeah,
a culture of immediacy too,
yeah,
and to be like, I mean, one of the things that I take a lot of pride in at Boston Dynamics is there's just a lot of like quality and honesty to what we do, and we're very upfront about the hard work and putting that in. And there's no shortcut. I mean, I take shortcuts all day with other stuff, with with like all the administrative work and email and interface design sketches and all the wonderful things that I can kind of just offload on agents these days. But when it comes down to, I think, the core set of things that have to be done to break new ground and to innovate in this field, it becomes it becomes very human, and it becomes slowed down, and it becomes social. And that's I think that's a good thing.
so true. Yeah. Well, welcome to Machine Minds, everyone. This is a very, very special episode. I didn't even tell Brian this, but this is our 150th episode. We're in the new
What an
studio.
honor.
Yeah, I know. We're in the new studio. We got the new logos, 150th episode. And we have an awesome guest from an awesome company that everyone knows. And I'm joined with Brian Ringley, HRI Designer at Boston Dynamics. Thanks for being on the show.
Oh, thank you so much for having me.
It's my pleasure. I've been really looking forward to this. So let's jump into it.
Thanks for not punting me to episode 151, because I wasn't.
No. I'm really happy to have you here. It's like a nice little milestone here for me personally as well, because obviously admire what Boston Dynamics have done, love all the videos, love the technology. They're obviously a standout company in the space and have been for years and years. And I think a lot of people aspire to be like them. So it's a great milestone and like a nice way of putting a stamp on this 150th episode. So yeah, let's get into this because I'm want to set the stage really for our listeners, because your path here to where you are right now at Boston Dynamics isn't really that typical robotics resume, right? Because you started out as a CNC and industrial robotic arm programmer, machinist, and then went into architecture as a facade modeler and BIM developer. How did those two worlds end up feeding each other?
Yeah, well, you get a lot of sort of young people like looking for mentorship around building a career, and they see that you have a job at Boston Dynamics, and they want to be there. I totally get that, and I sometimes struggle to be like, well, how much of this was like my own free will, and how much of this was a victim of circumstance. So I've always been I've had an inherent interest in technology and machines for a long time, and specifically an interest in the way that we can kind of work together on some kind of level of intelligence with machines, usually to build something, right? Because I come out of architecture and construction. So when the recession hit in 2009, when I graduated, I just wanted to be an architect. Technology is part of being an architect. I was happy with that. I just wanted to be kind of a traditional designer. And that's when I kind of pivoted to, I'm going to start to get into digital fabrication and computational design and kind of think about the affordances of all of these descriptive CAD languages, all of these fabrication methodologies, subtractive and additive and assembly, and kind of like ply my trade there for a while and understand what it means as a human to design versus collaborating with the machine. And that led through a number of kind of academic positions and then back into practice where I did, mostly facade modeling and environmental analysis and things of that nature. And ultimately, when you work in architecture, everything's very kind of siloed when you deliver a building between the disciplines, because there's liability, and that's just the way that the business is practiced. So I was like, we're building these super intelligent models that could be used more directly to construct buildings, but they're not, because then the person constructing the building, engaging in the means and methods kind of on the general contracting side, is assuming responsibility for like software that I wrote on the design side. So we can't do that. This is when WeWork blew up and was hiring, any architect professional who knew how to use a computer, essentially. And what was cool about that was the vertical integration piece, right? Because you could work on software, you could go out in the field and see that deployed into construction robotics, into automated layout, into things like that. We were literally building a factory to build the building components. So you're engaging in mass manufacturing. So it was really like the fantasy or the dream that myself and my kind of peers had always had about the application of technology to design and construction. And that led to Boston Dynamics and robotics, because at the end of the day, when we were trying to really get into robotics, we couldn't get enough up-to-date information about the state of construction. We actually had to, go out into the field or rely on people automatically collecting pictures. And we said, oh, can we use drones? Can we use this, that, and the other? And then I saw this video in 2018 of Boston Dynamics using the Spot robot. And I said, oh my God, it's time for my cat to wake up and make an appearance. Here we go. And,
hello.
Pause for possible editing, or we think this is funny and keep it in.
This is great. No, for anyone watching, we've got the cat being removed.
So, we get to the point where we see this video and I'm like, this is an extremely exotic type of robot. Like I was familiar with the legged robots from Boston Dynamics, but I didn't really think of them as having any kind of like use case or purpose. And I said, oh my, this is the way potentially to navigate these complex construction sites. And well, one thing led to another. We tested it. They had an incredible SDK because it was originally developed kind of as a development platform. We could connect it to our own construction management software. We proved that it could deal with the terrain and kind of change the environment to a large extent of construction site, and do it autonomously. So that was about the point where they were saying, hey, we want to kind of look into a construction product or construction application for Spot. We need somebody to look for product market fit there. Would you like to join us? And I took that leap. Yeah.
Awesome. Was that the specific moment, or was there another one in the construction and fabrication world where you thought, robots are going to be the next tool that I really need to understand deeply? Or did it just coincide with them saying, hey, come and work for us?
Yeah, I mean, robots kind of as a concept are really just like, the application of physical technology at the frontier before it's like a useful product or implementation. What I love about robots is they're like the aspiration. They're the absolute like edge of what we can achieve. And, once they become useful, like a dishwasher, we just call it a dishwasher or whatever the case may be. But I did, my gateway drug was definitely industrial robotic arms, which, not quite full stack robotics the way we apply the trade at Boston Dynamics, but nevertheless is a good introduction. And in my teaching, you could say, all right, here's how you prepare a digital model for 3D printing. Here's how you prepare a model for like CNC machining. But when it comes to industrial robotics, you get to also invent the tool type itself, right? Because the robotic becomes just this general kinematic platform onto which you can develop your own custom tooling to manipulate whatever material you want to use. So I really liked it as an educator because it was like, oh, you take a huge step back and you kind of say, okay, like, we want to work with thermoplastics and maybe we want to form them. So we actually have to design a specific set of tooling on the robot arm to both like hold a piece of plastic and manipulate it over a heating element and move in the right way to form it relative to the model. So you kind of expose the students to like a broader set of thinking, where part of the design exercise was the entire ecosystem of the intelligence of the material, the affordances of the tooling, and then ultimately what kind of like machine platform are you working on to allow that work to be automated.
Makes sense. So let's talk about your role at Boston Dynamics, because you've been there for a while now. And can you share about your time there and how long you've been with the company, what you're focused on, and what roles you've had along that journey?
Yeah, I've been with Boston Dynamics about 7 years now. Like I said, when I came in, it was, I believe the role was called Construction Technology Manager. And at the time, Boston Dynamics was small. The team was very small. We had just started, we were launching the commercialization of Spot under SoftBank ownership. And so it was a small team. So like I was doing a little bit of like sales, a little bit of product, but it was mostly kind of like a business development role, right? Because you're going out and you're doing the product thing where you're interviewing the user and you're understanding use cases they might have. You're applying your domain expertise from construction, and you're just looking for like, is there anything with product market fit? And we kind of knew early on, and from my experience as a customer before I joined, that reality capture was a good place to start. This was essentially a mobile sensing platform. So the sensing type in construction would be, things like 360 photography and laser scanning to build kind of an up-to-date digital model of the actual progress of the building, how it's actually been constructed, and then use that to measure it against the design intent to make sure that everything's where it's supposed to be and done when it was supposed to be on schedule. And as part of that, finding partnerships, we actually did a joint product with Trimble, and that also really stress tested our SDK in terms of them being able to develop spot control within their own platform. And I think a couple of years into that, we were doing other things too, right? Construction wasn't the only market we were testing Spot in. We had been doing a lot of stuff in more industrial environments, and we had started with the basics of RGB imagery and thermal imagery, and then thinking about, okay, what types of things overheat and have temperature thresholds, and then starting to layer other sensing modalities on top of that all kind of related to enterprise asset management, so that we were, essentially detecting issues before they happen to maintain uptime, preventative maintenance, essentially. So that really started to take off. And we, when you're applying the kind of crossing the chasm playbook, one of the lessons there is like, you really need to focus on like the one thing that builds a broader market with your customers. So he said, hey, we have all of these fantastic partners in construction, in Trimble, like a Geosystems, Drone Deploy, who, by the way, Drone Deploy got, there was an acquisition announcement by Procore this morning. For any contact people out there, that's kind of a big deal.
Really? I
Yeah.
haven't. I'm behind on my reading for this week, in
Yeah.
all honesty. So,
Yeah, they
oh
were
wow,
valued
that's huge.
something like almost 900 million. Yeah, it's cool stuff. Good for them, and
Yeah, yeah.
represents an investment in, essentially physical AI by one of the largest
Mhm.
players in the construction documentation space. So that story lives on, is the point.
Yeah.
And Field AI now is kind of an emergent player in that space, doing some amazing things with their own foundational models, which is a different approach. So we knew that was in good hands, and that's the beauty of having a partner ecosystem, and that we needed to double down on industrial inspection. And that's when I became a true product manager, because we knew that a big feature of that was, we needed to shift our software interface to be facility centric. We needed to shift our mentality from the robot is the product to the robot is a means to an end to whatever, the product is with value creation. So during COVID, we had started developing remote operation software over the web, because that was the only way to demonstrate the robot, because there were a lot of restrictions around physical gatherings and people just couldn't travel the way they were before. So we just allowed them to dial into our headquarters, drive the robot around, and kind of have a conversation about its capabilities and their use cases. And over time, that kind of evolved into one of the primary ways of operating the robot, through like a web application. But a big part of pivoting to taking the industrial application seriously was like, the first thing you should see is like the health of your facility. And I thought one of the most intuitive ways to do that was to just go to the blueprint, to just have a, visual rendering of the blueprint, to see where your fleet, is located, where robots are currently walking around in your facility. And then most importantly, to see where issues are arising, where anomalies have been detected in that floor plan. So by virtue of my background in, architecture and construction documents, that was kind of my first role. And there were there were kind of funny lessons there as a product manager where like when you're too biased or have too much experience in that field. I remember one of the things was like, okay, well, you upload a blueprint as a bitmap, and then in order to scale that correctly to real world size, all you need to know is the scale of that drawing and the DPI of the image you uploaded. It turns out that that's not just a skill that people have offhand. It turns out that most, PDFs or blueprints that facility people have, just they don't know the scale.
Yeah.
So I kind of just reverted to the old architect tricks of like, well, standard doorways and stairwells have about the same width. So if you can get a measurement on that, then we can do some arithmetic and we can figure it out. So there were some like UI stumbles like that, right, where you're like too biased to the problem, but that's a minor thing, but we did end up like pivoting this whole thing to, your homepage is what we call the sitemap. We've since extended that to give you more of a like photospherical immersive view, because these robots just by default are taking imagery as part of their sensing and part of their autonomous navigation. So, or as I like to say, they just kind of like passively off-gas reality capture. So it's like we might as well capture that, and that way you can get your kind of like top-down view of your entire facility, or you can actually enter it, and then you're kind of in this photospherical view. You can get interrogate it that way. So that was the big pivot, and that was my big like product management intro moment.
Yeah.
And then after the launch of Orbit, I think shortly thereafter is when I started transitioning to Atlas. But at the time we were in stealth about productizing Atlas. We were, it was not public yet that we were electrifying Atlas's actuation in preparation for productizing the Humanoid.
Interesting. Yeah. There's a lot there. And I mean, it sounds like that reframe was so important for customers as well, for like sitemap being more than about the facility or more than the robot itself.
Yeah, and the like the big picture thing for me was just that robots are really cool. We all love them. We take a lot of pride in building the best robots in the world, but they provide value by being more or less this invisible physical background process
Yeah.
that achieves some other aim. And our job is using, primarily software interfaces to make it front and center that those machines are creating value.
Yeah. Before we jump into Atlas, because who doesn't love Atlas? I'm curious, what did Spot need to prove to construction customers before anyone could trust having Spot on their job site every day?
Yeah, well, it's an interesting thing, because if you're not building something, right, if you're not putting a piece of material and contributing to the construction, it's hard to say this is like a direct value add thing. But we know surveying and project management is important, and it all kind of is bundled under risk management. You have to know what's going on. So we were always trying to tease out the right metrics, right? Like, what's the value of having like computational certainty that like a scope of work had been completed by a certain date to help automate payments. That was like a huge value driver. Another one was just safety. Hey, because if you have something that's just feeding other systems with imagery, well, this is the dawn of all the computer vision tools. So we can run safety audits. We can make sure that everyone's wearing PPE. We can make sure that we're keeping a tidy and neat job site to remove tripping hazards and things of that nature. So safety was also a big driver, because you can't just say, hey, now instead of laser scanning only once a month, you can do it every day. And people are like, okay, so now I just have like a museum of point clouds, or I have more data I could process. So I think the big challenges there were, one is margins are really tight in construction. So when you're making these ROI arguments, you really had to be like pure automation. And even something like walking manually operating the robot for the initial path to record whatever it was going to repeat was deemed by some to be too much. And if you look at like the field AI approach, they use like things like frontier-based exploratory autonomy, where you can kind of like reasonably bound where the robot's allowed to go. Don't
Yeah.
wander off forever, don't go into these particular areas, and you actually let the robot explore and build the map and just get going. So, or it's also called pogo, power on and go. You're just like, you have this robot dog in the back of a pickup truck. You just drop the thing off on a site, let it do its thing. And that was kind of the dream, right? So there was this insane pressure that there could be like no manual setup or configuration, or commissioning work, which is really tough. And then on the back end, even if everything works perfectly, you just have all of this data, some of it quite heavy, images much later, but nevertheless, how do you actually process all of that on the back end? How do you generate useful analysis out of that that's like meaningful for your project? And I remember early on in conversations, like in particular with like going back to like the drone deploy reference, when they started coming out with kind of tooling around different vision models that could, this was basically like right before VLM became a thing. And now we have VLM, and it's like, okay. And we have this in orbit now too, which is like, you don't have to tediously kind of go around and identify things in your site and manually configure everything you want to be done, or have counted, or this, that, and the other. You can start to have a conversation with your construction site or with your industrial facility. So I don't remember like quite when that tipping point happened, like 23 or 24, but it started to become clear that if you couldn't have a conversation with all of this data, then you weren't going to be able to generate value out of it, because it wasn't, there's lots of talks about building data sets and stuff, but like the data wasn't inherently valuable from the perspective of generating an ROI argument for Spot.
Fair. And they're very difficult environments as well, because they're like unstructured, they're forever changing. There's obstacles, tools, like ladders, dangers.
We used to be like, oh, well, there's like static environments like a factory, and then there are dynamic environments, structured sites. But I was like, no, really, like a factory is dynamic. There is no static. And construction it's chaos, and it's ephemeral. The thing that's there one day might just be in purpose to something else that's the other. It's inherently like changing, and then once it's a fixed thing is when we're no longer concerned with it.
Exactly.
So yeah, it was definitely an immense challenge to be like, okay, well, surprise, all the drywall went up today. So this huge, vast data center that used to just be light gauge steel studs is now completely clad, and you have these partitions, and figure it out.
You can't walk through those. You can't walk through those.
You can no longer walk through the walls. And this is also when I was like, there's probably more upfront intelligence, you could glean from building information modeling, right? Like the design intent should basically say, this is the phase, but it gives you like, this is the basic spatial structure that you should always be navigating. But there's pitfalls there too. Like things aren't always built as documented, reality and physics take over, and there's we were trying to solve that problem with the robot, right? So until you can establish like a chicken and egg problem, which is like, well, can we rely on design data for its actual physical construction? Well, here's a tool to do that. Well, this tool also would benefit from that being accomplished.
Fair. So Spot, for anyone that doesn't know, which I'm sure all of our listeners do, but Spot is obviously the robot dog. Boston Dynamics has probably the most famous robots in the world at this point. And then Unitree's videos are doing their thing, but everyone knows OG Atlas, the hydraulic one, Spot, the yellow dog that walks around everywhere, and now the new Atlas, which is super cool. And anyone that watched the World Cup, you would have seen it appear there and everything. And there's been a ton of really cool demo videos and stuff. So you've described Atlas as a product whose capability services effectively unbound. What does that actually mean for how you design the interaction model?
Yeah, well, it really blows everything up, right? You have to kind of forget everything you've ever bothered to learn about programming robots, or frankly about how software works. And it's the same thing that's been happening with with having like agentic methods in software. I'm constantly pointing to references. You know, as a designer, I work a lot using tools like Figma Make or Claude Design. And it's kind of shocking to me because it's like you're in some kind of environment, right? Like you're in the Claude Design environment, but once you're in there, you can kind of make anything. And you can even make meta applications in there. So you can make applications that build applications. And it starts to become a little bit mind boggling about like how you frame problems um, to even come up with a design solution. Part of the reason that I've always wanted to work on the technical side of things like architecture is I don't like unbounded problem spaces. And architectural design, right? Designing for a client, coming up with a vision was always a little bit too unbounded for me. And I'd rather, okay, you think about the wacky shape and then I'll figure out how to convert that wacky shape to a bunch of rectangles so we can actually build it. So it immediately put me in a very uncomfortable place as a designer and put a lot of value on creative thinking over just like raw execution and technical know-how. And you try to take cues from developments in kind of the agentic UX space overall. But at the end of the day, it becomes very wide open. So we've essentially settled upon, you know, a general stack of generative models. And you start from the very basics, right? You start from, can this robot walk in balance, right? That's always been our forte. That's always been our strength, but we used to use something called model predictive control, which I describe as like, you know, you actually write math for how a thing stays balanced while it moves through the world. And, you know, then came along, you know, reinforcement learning and in simulation. And so, you know, we could all of a sudden it's like, oh, okay, we can demonstrate like the ideal example of a backflip or natural walking. We can do that through animation tools, or we can do that through motion capture, or we can do that through teleoperation. But we can have that golden example. We can run a simulation a bajillion times until we like come up with that thing. And then we have this like robust policy that underlies everything else. And then, okay, we layer in manipulation on top of that. And this kind of like balance and basic locomotion and whole body manipulation are not fundamentally separate problems. It's just that you're kind of like, what are the available technologies and methods that will get us to doing something productive for Hyundai in a factory sooner than later? So, okay, when we get to the whole body manipulation stuff, we start to get a lot more into the hands. We need much more specific data, and we need actual like expert demonstration of those tasks. That's where we kind of layered in a lot of the behavior cloning stuff. And then on top of all of that, you actually have someone who ultimately has to talk to the robot and instruct it what it needs to do. And there needs to be a reasoning model. Like, is there a semantic understanding about what a particular part is, what a particular rack is? How do you convert factory system instructions to those semantic concepts? How do you know to do a thing one time versus 10 times in a loop? How do you know what to do with task exceptions? Like if you drop a part, you need to take that out of inventory because it's damaged. So you start to get all this stuff where like text is really useful. And we can start to have those reasoning models at the top that kind of filter down. You know, so there's an agent harness. We can still rely on traditional tool calls as needed, but then we can also go down, you know, into that VLA layer to do the task. But all of that is just the technology to prove that you can run an end-to-end autonomous policy and do something useful. To say that I can take an order from a factory system for, say, automotive sequencing, something we're publicly focused on right now, and I can execute on that with an autonomous policy. And that policy is something that runs with a certain amount of quality relative to a baseline. But we also have like in the loop eval tools where we can find gaps in the distribution, collect whatever data we need and retrain that. So you have all of this infrastructure and, you know, agentic software stack, but none of that really answers the fundamental question about, I bought a robot, how do I interact with it and tell it to do something brand new? And that remains, you know, a really big question. And, I still believe that a lot of that will boil down to coming back into like Orbit, our web application, and coming up with new and creative interfaces for essentially authoring applications. And, a lot of the team is heads down now on a set of like initial tasks that we're doing and deploying, like, as we speak in Hyundai automotive environments. But I'm also thinking like, it's Horizon 3 thinking too as a designer, where I'm like, yeah, but what if it could do anything? What
Yeah.
like anything?
Yeah. Well,
There always has to be some constraint to not drive yourself insane. But like, but if I wanted Atlas to walk through Boston Dynamics headquarters and water all of the plants on some cadence, okay, what does that look like? Can I use the same set of software interfaces and the same set of kind of systems backing that to achieve that successfully as I did for automotive sequencing? And if not, what's the disconnect? But what I like about it is it finally pulls us out of this world of like bespoke like interface design. We spent so much time building like the spot inspection interface, and we can't do that. That's not sustainable. And in fact, the breakthrough of Atlas it's an economic breakthrough rather than a technology breakthrough, in the sense that anything that Atlas is going to go automate, like say in the context of a factory, you could do it with bespoke hardware. You could do it with bespoke robot morphologies. And I've watched machine minds before. There's always this kind of conversation around the task specific morphology versus like generalizing in hardware. And there's a place for all that. I welcome all forms of robots in heterogeneous fleets one day in these factories, but the economic breakthrough comes when you have a single hardware investment that can be retasked solely through software. And that sounds nice, right? Oh, great. Like I only have to buy one kind of robot and all of a sudden it can kind of do anything. That's a breakthrough if you can prove that works. But then on the other side of that is like, okay, well, I also don't want to have to build a million software interfaces. If I retask this thing 1,000 times, I don't have to build 1,000 different pieces of software. So that too has to become part of this kind of generative and generalizable methodology. And
that's
then
fair.
you also have to be able to ask questions about when you need an interface and when you don't, because sometimes the interfaces already exist and you're simply trying to plug into them. So it's a really fascinating and challenging design problem.
There's so much to think about, but like you said, you have to like know where the limit is before you drive yourself crazy.
Right.
You said to me previously that hardware alone won't revolutionize automation and you need agentic AI reasoning on top of it. But where do you draw the line between what the hardware needs to get right and then what the AI brain needs to get right?
Yeah. This is another classic debate on your show too, right? Like it's like, who's going to win, right? Somebody's going to come up with the perfect AI brain, and then like all hardware, is commodity.
Which it's a tall feat, to be honest with you. But
right.
Yeah.
Is commoditized or whatever. I always have to pause and try to remember commoditized versus commodified. There's a nuance there, but basically all of a sudden, like, well, the value is in whoever controls the future of physical AI is whoever controls the brain.
Mm-hmm.
But what we're fundamentally talking about is like some kind of physical thing that needs to interact with these challenging environments. So it will always matter to have a certain amount of capability. And I don't know if that capability is something that anyone's going to get for free just because we have AI now. That's still going to require really high quality, reliable machine design. And it's also going to require building a whole business around that stuff too. Like if you're deploying machines out in the world, are they field serviceable? Did you properly design for manufacturing to scale? And like, can this thing run and run and run in challenging environments and be effective? And also, did you get all the details right? The strength to weight ratio, the range of motion, all of these specs. And, early on when talking about commercializing Atlas, there was so many meetings around like, what's the perfect strength? What's the perfect flexibility? What's the perfect reach? And if you're ultimately looking for a design that can do everything, you're saying, well, okay, we're not going to get it right the first time, right? So we're going to go through these,
Iterating.
yeah,
Yeah.
through these iterations. When we were at CES earlier this year, we were demonstrating like the research version of Atlas, and like simultaneously announcing like the first kind of, design for manufacturing purpose built
Version.
one. And we'll continue to learn and iterate, and yeah, you're not going to solve everything at once, but the point is that I still, the more I kind of learn about these stacks, and like, yeah, there's a reliance on that reasoning to get the hardware to be valuable and do the right thing. The hardware also has to be highly performative. So it's a
Yeah.
both. And
Fair.
there's like, I don't think there's ever going to be like a dominance from one side or the other. It's the same way I feel about humans. I'm like, we're always, our minds can only handle so much. We're always abstracting
Yeah.
things into, oh, our mind is separate from our body. That's not true, right? Like an embodied intelligence is a full kind of blend of both. There is no meaningful distinction between those two things. And I think the same is true of physical AI. There will ultimately be no meaningful distinction between the physical capabilities of the actual robot hardware and, the various pieces
Yeah.
of software and policies that drive that.
Man, I have so much that I want to cover with you. I feel like I need to book in another episode very quickly. But before I jump off from Atlas, I was curious how much of Atlas's signature look and feel is HRI design versus, pure engineering?
Well, that's credit largely to the industrial design team. And that's led by Aaron Abroff. And he, was that team works very closely with the mechanical designers. But again, it was all about this design for manufacturing piece. So it was simplify, simplify, simplify. And one of the first things is like, okay, we're gonna build our own high performance actuators. The fewer of those we have, the better. So not counting the hands, there are 2 of those throughout the entire robot. So if you only have 2 actuators, then the kind of casing around the actuators will look similar and start to develop a kind of basic geometric language. Um, and then, safety is a priority. We don't want pinch points, so we utilize the offset joints. We kept those as simple as possible, as easy and cheap to manufacture as possible. And you start to develop a language where a lot of your limbs, whether it's upper and lower or arm versus leg, look quite similar. And then couple that with the fact that these joints are continuously rotating, infinite joints, which means that like in a lot of cases, we gave the robot a face, and there's a front to the torso because the batteries go in the back. But in a lot of the other cases, this is a weird morphology where there isn't really a front or a back, and knees and elbows can invert as needed. And all of that is just to say like, well, why settle at the limited way that a human body can work? Let's push that and see what superhuman range of motion looks like, and um what kind of like ambitious tasks we can achieve in very tight spaces is always really interesting. Yeah, so you start to get these like emergent behaviors based on the affordances of that kind of wildly free kinematic model coupled with whatever task you're trying to accomplish. So, and also perhaps most importantly, is we are building a tool. We are building an industrial robot. We want it to look like an industrial robot. When you look at Atlas, I think that you understand like, okay, this is a thing that I put in a factory and it does useful work for me. This isn't like trying to trick me into thinking it's a human. This isn't my friend. We want it to be like friendly and approachable in the sense that like we don't want technology that's like scary or intimidating.
Yeah.
We want it to be very clear that this is something for utility.
And it
And
looks like that.
yeah,
Yeah. It looks
yeah,
like that. It looks rugged, capable, but
yeah,
like you said, it's not trying to be someone's companion.
yeah. And I like
Um,
how the evolution of its design, the interesting ways in which it diverged from the other humanoids on the market,
right.
which I always
Yeah.
love. And I love that, by the way, about the Animal, the Spot competitor. Like, I love how different that robot looks from Spot, because to me, that's 2 great companies full of great minds testing out different ideas in the world. And the more the more you have kind of sharp divergences like that, I think the more you're going to learn as you apply these robots to customer applications, and the whole kind of C level for that particular type of robot rises.
Sure. No, I totally agree. I totally agree. Yeah, it's nice to see such different visuals when you're looking at them, and you can distinguish different companies, different designs, even if like use cases are similar. But to me, you know, without naming some of the names of these companies, but some of them come out and I'm like, excuse me, some of them come out and they get released and I'm like, didn't I see that last week? Or why have they raised money? Didn't the other one just do the same
Well,
thing?
there's that, and then there's also some of the humanoids are like, so why is that so anatomically correct? Or like,
Yeah.
why is that so
Yeah.
gendered? And it begs a lot of bizarre, I
I
think,
know.
social questions that I'd like to stay well away from, because
Yeah,
that's not the thing that I'm trying to achieve in the world.
for sure. Speaking of CES, which you mentioned, you guys announced the partnership with Google DeepMind as well, and
Yes.
bringing Gemini Robotics into Atlas. Can you talk a little bit about that and what made DeepMind the right partner?
Yeah. You know, and I was a part of those like initial high level discussions, but there's an obvious thing where it's like, if I need to apply top level reasoning down to our kind of capable hardware, how many companies in the world have the data sets to build really, really advanced and sophisticated, you know, essentially text-based generative models? So you really have to look to those companies that are capable of doing frontier AI models and kind of figure out how you want to work together. And I think there's a benefit on both sides. I mean, there's a lot of things that where Google, we don't have the text corpus you have from the internet. So when you start to switch this thing from text tokens to physical action tokens to try to create behavior models, you have to go out and create that data set yourself. It's not just something that can be farmed or scanned from books yet, right? You know, eventually maybe they'll just scrape YouTube of every physical action anyone has ever taken on video on the internet, but it's a little bit more sophisticated and nuanced than that. So, you know, we offer them this incredible platform for that physical data collection and for testing out their reasoning models on robots. And I believe they just launched a new embodied reasoning model 2.0 today, Gemini ER2.0 today. So another thing that happened.
Cool.
It's an exciting morning.
It's an exciting morning. Look at that.
Yeah, a lot going on. And also we're very like Google cultured. Boston Dynamics at one point was part of Google. There's still kind of remnants and artifacts of that in terms of like the way we work and using, you know, various Google products. So I think it was a good cultural fit too. I've enjoyed working with that team. And it just gives us access to some of the latest and greatest reasoning models. And then for us to kind of build the systems that flex those on our physical robots. And then on the other end of it, they get access to a really incredible platform to test themselves and to go out and collect physical data. So it's been really cool. Yeah.
Very cool. Last question before I want to jump into this quick rapid fire round with you. If Atlas succeeds at scale, the scale that you guys are kind of aiming for anyway, in theory, what does a factory floor look like in 5 to 10 years?
Yeah, the software defined factory, right? I mean, I think it will look like a bunch of different robots. I think you'll still have a lot of the systems you have today. I mean, things are changing about the way that product moves through factories already. That's going to have an influence. If you think about, there's been so many supply chain disruptions, so companies are getting more agile about the work cell itself and saying, I really don't think we can have fixed work cells anymore. We need more of the line to be mobile. Introduction of giant AMR robots to kind of move inventory and tooling around. Software systems that can accommodate changes and reconfigure that line. So it's brought a lot more mobile robots into the factory, in addition to all of your traditional like static arms and other like fixed industrial automation systems. You have things like Spot roving around to kind of perform the mobile IoT functionality. Not everything needs to be measured at like 2000 hertz at the source. So you have these roving robots going around, essentially performing quality control. And then you layer in this idea of generally capable humanoids, and that kind of fills in the gaps, right? Like, where do we still have places where we have dull, dirty, or dangerous tasks in the factory that we want to automate, and that also help with the bottom line, and help with flexibility too, because we talk a lot about just like pure automation. But again, if you have a retaskable humanoid and your work cell has to change, or your material or your supplier changes, which are things that happen more and more. Again, this is really like risk management, like supply chain risk management, as you get this new level of flexibility. So I think we're just like one facet of many things that are happening to factories these days. Also, the virtual commissioning of a new factory or a reconfigured line, thanks to like NVIDIA Omniverse and like GPUs in the cloud, people are really able to simulate like end-to-end product movement through entire factories in a way that simply wasn't scalable before. So there's a convergence of all of these things. So I think it'll be very heterogeneous. There will be many more types of robots. I don't think it makes sense for Atlas to replace literally everything that happens in a factory. It's not, it doesn't make sense.
Yeah, it doesn't make sense. No,
but it definitely is like this amazing, like drop-in kind of gap filling,
for sure,
tool that I think will be an amazing addition to like any factory workforce.
100%. Yeah. There's too much now that makes sense with single use or dual use robots.
Yeah,
especially within a factory or a logistics setting, that a humanoid factor just can't compete with and doesn't make sense. But then there's so many other applications that it does make sense for, right? Okay, rapid fire. Let's do this. Hardware or AI brain, which one loses you more sleep?
Makes me lose sleep.
Yeah. Which one do you worry about more, hardware or AI brain?
I worry more about being successful with hardware. I feel it's more my responsibility to probably contribute to that.
Yeah. Most overused phrase in humanoid robotics right now?
I mean, AI, right?
Physical AI, yeah.
Yeah, I gave a talk the other day, and I was like, it's like digital twin. These words that take on so much meaning as to mean nothing. And I'm like, well, can you talk about like what the AI actually achieves and put it in context? And you might not need to say it at all. I still can't get through a talk without saying like agent, because I feel like that does still have like a meaning. But yeah,
that's a good one. Human-like movement or superhuman movement? Pick one for Atlas.
I think that, well, it's interesting from the designer, the HRI perspective, right? Is it lends some, you have to balance it, right? You want it to move naturally in a way that builds trust. Like, this thing is stable, this thing moves efficiently, but it doesn't trick you into thinking it's a human or doing, or replacing people or something like that. But it also doesn't move in such a kind of unexpected way that it's scary or off-putting. So I think you want the natural human movement when you're talking about locomotion. I think the superhuman stuff comes more into play when you get into manipulation and actual like whole body task behavior.
Yeah, that's fair. That makes sense. So you're not picking one, I take it. Both for different uses.
I'll pick the superhuman.
Yeah, I probably would as well. One robotics company outside of Boston Dynamics that you're watching closely?
I think, this is one I probably should have prepared for. There's probably a lot of really good answers to this.
There's so many out there, yeah.
There are so many out there.
All right, top three. Or three.
Right. I mean, I like what Field AI has been doing because it's building off of like a lot of like the kind of area that I was used to be focused on. And I want to see successful deployment of robots for construction solutions. So I'm like
they're doing awesome stuff. Yeah.
In the world, we have some like, BD spin-off type things that I think are really interesting. There's like Generalist is a company with some false dynamics engineers that are really just kind of tackling the like universal manipulator interface for data collection faster problem. I think that's where, like, you don't need to collect data off the same hardware that the policies run on. And, you know, that's definitely like, we need to close that embodiment gap, as you have to learn the, you know, 14 gaps of robotics you're trying to close. That's the thing I should have said, is I'm sick of people saying close the gap. And then you look at like, there's just a lot of interesting applications of like the humanoid morphology. I like the way the Sunday Robotics robot looks. And there's the one, oh my God, I can't believe I'm blanking. The one that was acquired by Amazon recently.
Oh my. Fauna?
Yes, thank you, Fauna.
Yeah. Yeah.
And I actually got to interact with a Fauna the other day, and it was kind of the same. It was like the first, it reminded me of the first time I got to use a Universal Robotics arm, where you kind of like, it's a cobot. You can grab it, and you move it around, and you compose it to program it. And oh my God, that's really cool. Like I've gone from it taking months to really become an expert in industrial arm programming with like an ABB or a KUKA or a FANUC to, you know, I use this and I can kind of get it down in a day. And I had this like similar experience with the Fauna robot, where like you can go up to it and you can grab its hand and you can pull it along with you. And it freaked me out a little bit too, because it almost felt like when I'm trying to grab my nephew's hand when he's like running into the street, pull him out. It was like a little bit too close to that, uncanny, right? But it, you know, that team did a fantastic design. You think about, you know, the ability of these startups to kind of go from zero to fully functional humanoid in a record amount of time these days.
Yeah, it's true. I mean, they were really quick with it.
Yeah.
Teleoperation in 5 years, you think essential or niche?
For data collector, as an application?
Ooh, application.
As an application, I think you're always going to want that, because you're always going to have environments that are just completely unsafe for people. I've spent a lot of time in underground mines that they just blasted, and they haven't fully sealed yet, and, you know, they want to go in there and kind of check that out. I spent time in nuclear environments where they're doing decommissioning exercises, and you really don't want to go in there if you don't have to. And, you know, I've also been around, you know, people like when the New York Fire Department, right, deployed SPA into a collapsed building to just be like, let's get eyes in there right away, super low risk, and see if we can find anyone who needs help. And then we'll definitely send whatever we need to send in to save that person. But if there is no person in there, then we didn't risk it. And there's other things too, like, there's this amazing video of SPA on a SpaceX launch pad, like, and you would never be able to, like, I was looking for it. It was like a speck on the horizon, but the idea that you can get a sensor that close to a place where like a person couldn't be,
shouldn't be,
get whatever telemetry or whatever data you need about that launch or that landing, right, to improve upon that model. So I think there will always be strong reason to have like direct remote control over these robots.
Awesome. Last one word you'd use to describe working alongside Atlas every day.
Awesome, right? Like, that's the most like American bro answer.
Awesome,
but it really is.
No, it's true. Yeah, I can only imagine.
It's really nice to still feel a sense of awe and wonder, and to not get jaded with the technology. When you're in the lab, and it never gets old, when you're in the lab and you're next to an Atlas that's running, it just takes your breath away. And it feels so cool to be a part of being able to work on these things.
Yeah, I remember seeing Atlas. It was just like the model of Atlas at a conference I was at the Robotics Summit. And that was cool. I mean, he wasn't moving. Yeah, the statue. He wasn't moving or anything, but it's cool to see like the scale, and after all the videos and stuff.
They have a presence, for sure.
Yeah, they really do.
Really feel it. Yeah.
They really do. Well, Brian, look, thank you so much for being on the show. This has been awesome. I'm so glad I got to have you here as my 150th guest as well. It was awesome learning about everything that you're doing and how you're designing the interaction layer and where humanoid robotics actually headed, because I think you guys are definitely front runners in the game and you've been at it for so long. So I thank you again.
Well, the pleasure is all mine. Thank you so much for the invitation.
My pleasure. How can our listeners learn more about you and Boston Dynamics in general?
Yeah, you can find me, Brian Ringley, on LinkedIn. I've recently got back into Twitter. I'm giving that another shot. I feel like there's been an awakening of robotics and AI conversation on there. And yeah, check out our website, bostondynamics.com. There's a lot of great like webinar content, information about our robots. But the most fun place to go is our YouTube channel. Go back to those like OG videos of like Atlas walking in the woods or people pushing Spot with a hockey stick.
All right, I might go down that rabbit hole myself. I always end up down an Atlas rabbit hole. But yeah, this was awesome. Thank you again, and I look forward to staying in touch.
All right, talk later.
Take care.